So we're still studying proportional relationships. We talked about scale drawings and scale factors with our shrinky things, but this is a different type of proportional relationship. It's called direct variation. So two quantities, x and y, show direct variation when y equals k times x, where k is a number and k does not equal 0. The number k is called the constant of proportionality. Proportionality. Okay, so that basically means that x and y have the relationship that they are changing at a constant rate of k. Okay, so the graph of y equals kx is aligned with the slope of k that passes through the origin. So basically, it's going to continue changing with that constant k, and it's going to go through the origin. The origin is 0, 0. So two quantities that show direct variation are in a proportional relationship. So one indication that you have a constant proportionality is that it goes to the origin. And the other indication is that you're going to have an equation that's y equals something times x. And the something is every time x changes, y changes in the same way. So for this one, it's going to be y equals 2x. All right. So now, you need to graph the ordered pairs in a coordinate plane, and you've been given a coordinate plane. And do you think that the graph shows the quantities vary directly? In other words, as x changes, y changes at the same constant rate. So to do that, we need to see, does it go through the origin? Is it a straight line? So we graph these points. 0, 0 is the origin. So as long as it's a straight line, I think it's going to be varying directly. Then 1, 6 is the next point. 1 up to 6. You have 2, 12 over 2, and my graph doesn't quite go up to 12. But with the points that I have, I can show that it varies directly. And when you connect those points, and really you only need 2 points for a line, the more points that you have, that kind of defines the line a little bit more for you. But you could see that it goes through the origin. It's a straight line. So I would say yes. It varies directly. I want you to use graph paper. Graph 2 or 3 of these points, and then answer yes or no. Does it go through the origin? Is it a straight line? And if it is, then you have a proportional relationship. If not, then you don't. Do number 2 now. Okay, we'll check number 2 when you get to class tomorrow. So now we're going to look at it in a table. In a table, can you tell if there's direct variation? Well, I'm looking to see if there's a relationship between x and y that's the same each time. So what can I do to x to get y here? Well, I can do 1 times negative 2. What about here? What could I do to 2 to get 0? Well, that would be 2 times 0. What could I do to 3 to get 2? It's not going to, what you see is that it's changing each time. This is times negative 2, this is times 0, this is not times 0, negative 2, this is times 1. In order for it to be direct variation, you should be doing the same thing each time to x to get your y. That's what it means to have a direct relationship. So now I want you to try B. Look and see if the same thing is happening each time to your x to get your y, and if it is, then the answer is yes, it's a direct variation. So you should try B now. You can also tell if you have a direct variation by looking at an equation. You can look at a graph and see that it goes through the origin, like we did in our first example. You can look at a table and see if you're doing the same thing each time to x to get the y. And you can look at an equation. And you can just put in values for x and see what y would equal. So if I said x equals 0, then I would be saying that something plus 1 equals the same as 2 times 0. Well, y plus 1 equals 2 times 0 is 0. And I could subtract 1, and y would equal negative 1. So when I do that, I should already be able to know that this is not direct variation. Because in a direct variation, I need to be able to go through the origin. The only way I'm going to go through the origin is when x equals 0, that y also equals 0. When I put 0 in for x, that y also equals 0. And this already shows me that it doesn't. I can put in more values to see if it's changing by the same way each time, but I already know by putting in 0 for x, I should get 0 for y. And since I don't, then this is no. This is not a direct variation. And the reason why is because it will not pass through the origin. In order to pass through the origin, x and y both have to be 0. So I want you to try B. Make a table, put in x equals 0, and see what your y will equal. If it equals 0, then you have a direct variation. If it doesn't, then the answer is no.